Hey guys, we are going to do the 6.2a notes, which are techniques of anti-deriving, also known as anti-differentiation. A lot of this is kind of review of what we did before the last test, so it's not a bad one to have in a video, hopefully. First technique is simply to reverse the power rule. So for example, if we have something like the integral of 2x dx, our function would be y equals 2x squared over 2 plus c, which simplifies to y equals x squared plus c. Second example for this type, integral of square root of x dx, and just like when we did derivatives, let's rewrite it, x to the 1/2 dx, so we will get x to the 3/2 over 3/2 plus c, and a final answer of, since we divide by 3/2, it's like multiplying by the reciprocal of 2/3, 2/3 x to the 3/2 plus c. Third example, the integral of x square root of x dx. So what we always want to look for with integrals, even more than derivatives, is there any way we can rewrite it to make it either easier to do, or in this case, so we can actually do it at all. So we can rewrite this as, since this is x to the first, and square root of x is x to the 1/2, it's x to the 1, technically 1 plus 1/2, which is x to the 2/2 plus 1/2, which is x to the 3/2. And if you can just go straight there in your head, that's cool too. So the integral of x to the 3/2 dx, we get y equals x to the 5/2 divided by 5/2 plus c. So y equals 2/5 times x to the 5/2 plus c. Our second technique that we'll use here, again, some of which we've already done, is reverse trig derivatives / use the integral properties. First example, if we look at y equals cosine of x, the derivative is negative sine x. So if we go the other way, if we want to take the integral of negative sine x dx, we get cosine x plus c. But what if we wanted to take the integral of sine x dx? Remember, what we're asking in our head a lot of the time, until it becomes automatic, is what do I differentiate, take the derivative of, to get really whatever I'm taking the integral of. In this case, sine x. So what do I differentiate to get sine x? And we know that the derivative of cosine is negative sine, so we're going to have to take the derivative of negative cosine to cancel out the negative. So the derivative of negative cosine is going to be negative negative sine, which is just sine. So that's why that works. Another example, the integral of 2 secant squared of x dx. Technically, and it doesn't matter if you write this step out or not, we can pull out that 2, and it's 2 times the integral of secant squared x dx, which is 2 tan x plus c. Or if you prefer, y equals 2 tan x plus c, since technically we're integrating a function. And if this isn't second nature yet, that's okay. Again, just remember what the derivative of what equals secant squared? Tangent. Here's another. The integral of negative 1 over square root of 1 minus x squared dx. This is all memorization. If you remember, the derivative of inverse cosine was, this. So inverse cosine x plus c is our answer. If you notice, sometimes I write y, sometimes I don't. Unless it's specified, you could do either. Last example in this section. The integral of 7 over 1 plus x squared dx. Could pull out a 7 times 1 over 1 plus x squared dx. It's always a good idea to pull out constants, or at least visualize pulling them out, so you can see kind of patterns or see integrals that you know. The integral of 1 over 1 plus x squared is inverse tangent, so we can just tack a 7 on. 7 times inverse tangent x plus c. Let's talk about exponential functions. I think this showed up on a homework. We talked about it some, I think, in the review. Exponential functions. I don't want that to be an x. I want it to be an asterisk. It's happier than an x. Okay. So if we think of derivatives first, y equals 6 to the x. Y prime was 6 to the x times the natural log of our base, which was 6. Just so you don't forget, this is a constant. It's not a particularly pretty constant, but it's still just a constant. If we want to take the integral of 6 to the x dx, we go the other way. So keep in mind, with a derivative of an exponential function, we multiply by natural log of whatever our base is. And so for an integral, we will divide by natural log of whatever the base is. So the integral of 6 to the x dx will be 6 to the x over natural log of 6 plus c. So here on the left with the derivative, we multiplied by the constant natural log of the base, and here we divide by it. You can leave it like that if you want. Otherwise, you can write it as 1 over natural log of 6 times 6 to the x plus c. Either version is fine. And here's another rule. It doesn't really have a nice name. I just said sometimes you need to simplify or rewrite. So, for example, and again, we've already done this, but it's a nice review before we get into harder / more fun integrals. Integral of x plus 6 over 3 dx, well, Hart method, x over 3, so the integral of x over 3 plus 6 divided by 3, which is 2 dx. So what's usually helpful, although you don't need this step, is to rewrite it as the integral of 1/3 times x, because that's what x divided by 3 really means, plus 2 dx. So y will equal, well, 1/3 times x squared over 2, which is going to be 1/6 x squared. So 1/3, we did x squared, and then we divided by 2, plus 2x plus c. Oops. So that's one way to look at that integral. I'm going to show you the same integral another way. The integral of x plus 6 over 3 dx again. Before you do anything, you can actually pull out the 1/3 and make it 1/3 times the integral of x plus 6 dx. And then we can actually split it again. 1/3 times the integral of x dx plus 1/3 times the integral of 6 dx. And so what we end up with, for kind of our two integrals, we have 1/3 times x squared over 2 plus c. And remember, technically the 1/3 is multiplied by the c, but 1/3 times a constant is still a constant, plus 1/3 times 6x plus c. So y equals this piece, which is x squared over 6 plus 1/3 times 6x, which is 2x, plus c. And again, I combine the c's because c plus c is still a constant. So this last piece, if it got a little confusing, keep in mind as long as you can do this integral, x plus 6 over 3, in some way, it really doesn't matter which way you use. I just wanted to show you different ways of rewriting. Okay, so hopefully that was helpful. Somewhat review. There's a practice worksheet for you to do, and then you can do the homework, which is on Schoology, and I put it in my subplans. Thanks a lot. Have a good day.